speak first, or are you going to go?
It's a pleasure for me to introduce our next presenter, Gary Hallmark, who is a well-known expert in decision management community. And first of all, people know Gary as the inventor of DMN field expression language. So he is responsible for a lot of good and maybe not so good things. It depends how people look at this. But he also was a co-chair of DMN task force. And after many years in Oracle, Gary recently started his own consulting business in decision intelligence and AI. And he will share his results in so-called pilot private verifiable AI system. And the word private is the keyword here. We did not hear it a lot, and it would be very interesting to hear this from expert in DM. Gary, go ahead.
Thanks, Jacob. So, agentic AI. The problem is not whether a language model can produce an impressive answer. I think we have all been impressed to one degree or another. It's whether we can explain, reproduce, and review the path that produced a consequential answer. Now, in the old days, when I said model, I usually meant either a data model or a decision model, both deterministic. These days, I usually mean a non-deterministic language model. In regulated environments like healthcare and legal, fluency is not the acceptance criterion. The system has to preserve identity, provenance, validation state, and an inspectable relationship to the source. This presentation is about healthcare and legal Q&A, but the pattern applies wherever we support decisions on private access controlled data. My thesis is that you should use frontier models, God models, if you will, aggressively at design time. At runtime, constrain language models to bounded transformations and keep authority in deterministic software, orchestration, if you will. Now, private does not necessarily mean on-premise. It means sensitive data does not leave your boundary, your trust boundary. The configured generative model in this implementation is from Google, Gemma 4 26B. Now, I chose this model 3 months ago based on the best model that would work for this application and work on my MacBook. Recently, more models around the same size and capability have been announced. I need to reevaluate. Now, data sources, if you look at the decision path, begin as structured FHIR, clinical notes and impressions, and legal PDFs. These sources are converted into typed, validated evidence records. Query, rules, review, and audit tools operate over those records. Gemma performs bounded language work. It does not become the source of record. In fact, the largest Gemma workload in my system is not chat for Q&A. It's distilling the legal PDF text into proposed structured evidence records. So I'll talk a little bit more about the problem and continue with the evidence model, pipelines, private runtime, a bit of economics and limits, and a brief demo. So I'll talk for about 45 minutes, then demo and QA after that.
Okay, just one comment. You're not advancing your slides in purpose yet?
Here you go. Here's one.
Okay.
But I'll go back because my surprise was to see why the evidence layer matters. First, consider which parts of the system are allowed to be creative. There we go. You already saw it. Giving it away, the runtime really should be the least creative part of the system. So frontier models, as I said, are useful during design for research, competitive analysis, high and low level design, code generation, mappings, rule drafts, synthetic edge cases, failure hypotheses, and whatnot. Their output is not accepted merely because a model produced it. It becomes a versioned artifact that people and tests can validate. So this is where broad model capability, God model, if you will, is especially valuable because exploration is needed and expected. But at runtime, known cases should follow explicit policies. Typed tool contracts, they should be validated, and state transitions should be logged. The agent decided does not provide enough information for an auditor, a clinician, attorney, or operator to reconstruct the result. The runtime may still contain generative transformations, but the application controls the source envelope, schema, validation, and admission rules. So initially, the dominant model workload is legal evidence production. Long legal PDFs are divided into bounded candidates. Gemma, that's the LLM, proposes concise, typed propositions from those candidates. Deterministic code restores the authoritative document and page provenance. It checks the schema, it rejects invalid records, and also deterministic code exposes failures. Clinical notes and impressions follow a related process, but at a smaller scale. Chat, summaries, and answers occur later. They consume the evidence produced by this pipeline. Generated evidence can be reused until the underlying sources change, which typically doesn't happen. In other words, data is typically added to legal cases or to medical cases in an append-only mode, so you can still use the evidence that you've mined from earlier source material. So even though the system is meant for Q&A against a particular patient's medical records or a particular legal matter, the system is not designed around a chatbot with retrieval attached. It's designed around a governed evidence collection that supports multiple downstream tools. So that makes the definition of an evidence record the most important contract in the architecture. Canonical evidence sits between source extraction and every downstream claim. So let's look at the fields of the evidence record. The canonical evidence is, again, it's validated, source-grounded proposition admitted under a shared contract. And this is the record. There's a ID that gives stable identity for citation and drill down, primary type. A statement is one concise natural language proposition supported by the source. Source and citation fields preserve the relationship to the source, whether it's a FHIR resource, a document, a page, etc. Facets, or like fields, that support exact deterministic filtering. Semantic slots assist in ranking and similarity matching. Temporal annotations distinguish dates carried by the source from dates asserted by a proposition. And salience supports review prioritization, but it doesn't establish truth by itself. So let's look at the three evidence paths. Legal text goes from a PDF span to deterministic candidates and signals. Those are given to Gemma for curation. And then if Gemma generates a proposition, it's deterministically validated against the JSON schema, and it becomes a legal evidence statement. The structured clinical path goes from a FHIR, that's Fast Healthcare Interoperable Resource. I'll try to expand some of these acronyms as I go. So it goes from the FHIR resource to deterministic normalization and validation, producing a healthcare evidence statement. Gemma is not needed in this path because there's no real natural language involved. Clinical text, which is also part of your medical record, goes from a clinical note or an impression to a candidate, then to Gemma for curation and validation. And that also produces a healthcare evidence statement. Primary type of that is clinical assertion. So healthcare evidence comes from both structured and unstructured sources, whereas legal evidence comes from unstructured sources only. And we want to keep derived output outside of the evidence. So roll-ups, trends, summaries, answers, recommendations, etc., remain derived objects. When they make a claim, they carry validated supporting evidence IDs back to the canonical records. So once the evidence contract is fixed, the agent's role becomes much narrower and easier to inspect. So let's reframe orchestration a bit. The system does not ask an autonomous agent to ingest an entire patient's chart or an entire 100-page legal matter and decide what to do. Fixed pipelines establish canonical evidence first. The orchestrator then coordinates bounded operations on the evidence. So, before LLMs, if we remember, not long ago, we had process orchestration and decision orchestration, and we still do. Traditional workflow code was often dinged because it accumulates nested branches, if this, call that, inspect the response, branch again. Now, this group sort of prefers a decision-oriented approach where you supply the current context, the tools allowed at the moment, a typed result contract for what you expect a decision to look like, and then the resulting state can be validated before the next operation begins. So decision orientation can reduce spaghetti control flow without surrendering authority to the language model. Back to the language model again. Now it changes a little bit when our focus is on question-answer orchestration. Natural language, and you can see the three pillars here. Natural language Q&A is an important tool for decision support, and you can view orchestration connecting LLMs with evidence. So let's break it down a little bit. Dynamic context contains only the facts, policy, capabilities, and prior decisions that are relevant now. Query time contracts cover 3 distinct steps. So Gemma translates a natural language question into a structured evidence query under a strict response schema. Then deterministic code executes that query using both exact and semantic matching. Then back to the LLM, Gemma receives only high-ranking evidence results, confidence dimensions. Gemma translates that into the grounded natural language response. And then decision envelopes keep the outcome, the evidence, the confidence dimensions, validation state, provenance, and escalation all together. So the design rule is use model-directed choice only when the choice is genuinely dynamic. Keep the extraction mechanics, the source identity, the validation, and the state transitions explicit. So the reference architecture that I'll show now follows directly from that separation of responsibilities. And the architecture that I'm using, there's one governed evidence core, and we have multiple domain overlays. And again, today I'm talking mainly about the healthcare overlay and the legal overlay. So let's walk down the source side. Structured FHIR for healthcare records brings codes, values, dates, and direct resource provenance. Clinical text, which is scattered throughout your medical record, brings symptoms, assessments, plans, reasoning, and impressions that may not exist in the structured records. And legal PDFs for the legal overlay bring text or OCR, layout, page mapping, sections, and document spans. So the evidence core is a governed collection, not just a vector database. Records are typed, cited, validated, and queryable. Exact filters and provenance remain first class even when semantic ranking is applied. Agents and generative models operate around the core, They don't replace it. Let's walk down the consumer side on the right. Evidence views provide exact and semantic queries. We have derived review artifacts that include roll-ups, trends, care gaps, timelines, and summaries. These are produced by essentially by rules. Then decision outputs include the grounded answers, recommendations. Mainly, I'm going to be talking about the answers today. Review tools have to expose the source and allow a person to accept, revise, reject, or escalate. So with that architecture foundation, we can look at two distinct pipelines: producing the evidence and then using the evidence. So let's define what we mean by RAG here, retrieval augmented generation. So in many systems, extracted chunks of text enter a vector store and are immediately treated as grounding. Here, extraction creates candidates, not evidence. Curation proposes evidence. Validation admits the evidence. Retrieval and generation then start after that boundary. So let's look at the production track. We start with the sources, structured file and notes and impressions, or legal PDFs. We have deterministic processing. We normalize the structured resources or extract bounded text candidates and signal metadata. We use Gemma to propose typed propositions from the bounded narrative text. We don't need that, as I mentioned, for the structured file. Deterministic processing, again, restores the authoritative source provenance, validates that what Gemma produces is valid according to the schema and the taxonomy we give it. We deduplicate if necessary and reject any invalid records. So the canonical evidence that survives, right, is what we use. It's typed, it's cited, it's queryable. And Gemma is carefully, sort of air-gapped to not allow to invent canonical record identity or legal page mapping or file resource provenance. Now, how do we use the evidence? Well, we essentially are using PostgreSQL. So we have exact filters available for IDs, primary types, facets, salients, temporal types, and dates. We can use semantic search, RAG, to search and to rank evidence, and the result is then a bounded subset of canonical evidence. So Gemma can translate a question, a natural language question, into a strict query. There's also deterministic routes for common cases. Gemma can translate supplied evidence into natural language for an answer or a summary or a recommendation. And the natural language output remains derived. It doesn't re-enter the canonical evidence collection. So the authority is split. Gemma can propose evidence structure, translate a question, and verbalize supplied evidence, but code owns the source identity, the citations, page and file provenance, validations, cache identity, exact filtering, and admission to canonical evidence. There's also a separate embeddings model for the semantic search. So they are kind of kept separate. The embeddings rank the possible semantic matches. They don't create a proposition. They don't establish any source relationship or decide that a record is canonical evidence. So healthcare actually shows why we need a deterministic path and a curated narrative path within the same evidence collection. So some of the FHIR resource types that we use: patient, condition, medication request, observation, encounter, and service request records. So we can read those directly from the FHIR server and normalize those into our internal evidence format. And that's all deterministic. Codes, numeric values, units, facets, and dates stay close to the source representation in FHIR. And direct FHIR resource provenance is retained. Now, for note-like text, which also appears in your medical record, it can come in through various, again, sort of attached to FHIR resources, but as natural language text, composition, clinical impression, service request, diagnostic report, document reference, and even we also support import from Epic, because that's, at least on the West Coast, a popular medical record system. So deterministic code cleans up the text and creates the candidates. Gemma curates those candidates into proposed clinical propositions, and then deterministic code comes back and validates. If it's invalid, it may ask Gemma to one time to say, here, you made a mistake. Can you repair your curation? And if it does, it adds that. If it doesn't, it just drops it from the curated evidence list. So a surviving proposition becomes a healthcare evidence statement. Then, let's see, we have longitudinal roll-ups in healthcare. So clinical review is often organized around a topic over time rather than a particular evidence type. And longitudinal roll-ups can bring together structured FHIR facts, note-derived assertions, trends, condition support, and medication reconciliation for a local clinical topic. And that's useful, but it doesn't always fit cleanly into one evidence view. So the roll-up remains derived and retains the supporting evidence IDs and source class, so the reviewer can move from the organized clinical story back to each canonical record. And the structured facts and note-derived propositions can be queried together because they share the healthcare evidence contract. And deterministic roll-ups, trends, timelines, evidence views operate on the same collection. Gemma always translates the compact, tight-balanced evidence projection into the required chart narrative. And we'll see an example of that when we get to the demo. So again, there's a boundary. Raw notes and candidate chunks are not evidence. Only validated clinical assertions join the canonical collection. Derived views remain outside the collection and point back to the supporting evidence records. Now, the same pattern becomes more computationally significant when the input is a long, irregular legal PDF. Again, the PDF is the source. The evidence record is a validated proposition. The PDF page is a source container, right? It's not a directly queryable legal proposition. So a useful evidence record expresses one source-supported proposition with a type, facets, temporal information, salience, document, and page provenance. And producing those records from a long PDF is actually the dominant generative workload in this system. So how does the pipeline work? Well, a Python package called PyMu-PDF provides text and layout rows when the text layer of the PDF is usable. Now, unfortunately, in PDF land, sometimes what looks like text is actually just an image of text. In that case, we have to use Tesseract OCR when the text layer is absent or unusable. But the extractor retains the page relationships because later citation needs to point back to the source document. We clean and recover the structure. You'll find all sorts of horrible things in these PDF documents. Repeated headers, footers, extraction artifacts need to be removed. Every once in a while, you'll find some dense form that we can't read, and we have to exclude that. And outline information, which is not explicit. It's interesting how these legal documents typically don't have an explicit outline, and it's kind of a challenge to reconstruct that, but it's very useful because that gives you a way to fence off what are the candidate blocks of text that you want to look for evidence in. And also, sometimes if you can't get the outline, you can at least get numbered paragraph structure, and that also helps. Typically, a particular piece of legal evidence doesn't span paragraphs or it doesn't span across headers. So code creates the source spans, candidate IDs, signal families, like it looks for legal keywords like, allegedly or must or is obliged to, looks for dates, things like that, things that can signal the presence of a legal proposition within a block of text. And the signals actually, they're just used to select the candidate text to feed to curation, to feed to Gemma. They don't decide the final proposition. Candidate generation also defines the envelope that Gemma is allowed to inspect. And legal time has to be handled carefully. It needs to be structured rather than reduced to one sortable date. So the contract distinguishes exact calendar dates, relative deadlines, recurrence and duration. An exact source date may be normalized to ISO form, but something like within 30 days after receipt of notice remains a relative deadline with a direction, amount, unit, and anchor intact. It's not silently converted into a calendar due date. So after we get these candidate chunks of text, likely but not guaranteed to have something interesting legal evidence, we give that to Gemma. Actually, we give it several candidates per batch, subject to a prompt size bound for efficiency. And Gemma proposes the legal primary type, the natural language statement, exact facets, semantic slots, temporal annotations, the salience, how important or relevant it thinks it is, and optional confidence. Basically, this is asking the LLM to rate its own work, so use a grain of salt with that. The 6 legal primary types are document, party, definition, event, directive, and consequence. The model proposes the proposition level content. It doesn't touch or author the canonical ID, the citation path, or the page mapping. So that's all sitting outside. And then code reattaches stable identity and authoritative source provenance, right, to the Gemma output. So Gemma can't hallucinate where it came from, right? And a rejected legal proposition receives one focused Gemma repair attempt. I think I mentioned that before. Out of something like, 500 curations, it might generate 5 or 10 invalid. And then when you point out, hey, this is invalid because you missed this, then it can focus a little bit more and typically can get all but maybe 1/10 of 1% of the total ones generated validly. And the same validation applies to the temporal type and precision, direction, amount, unit, and anchor. Again, notice the asymmetry, right? The model handles the language ambiguity, but the code decides whether a record survives. And why does this dominate the workload? Well, at least at first, a long document generates many bounded batches plus the small repair tail. And the good thing is that, once the evidence is cached, it typically doesn't change. So you can reuse it, ask many, many questions, about the patient, about the legal matter, and that all of those questions, QA becomes relatively fast. But the initial ingestion of the legal document can be fairly slow, and I'll get into how slow that might be in just a minute here. But anyway, looking at this pipeline, the last two pipelines, we can I'll explicitly point out every place that Gemma is used in my system. So as I said, Gemma 4 26B, 26 billion parameters, is the configured generative LLM that I'll use in the demo. And every item on this slide here is a bounded Gemma call. The orange one is just calling out the one that's most dominant, at least initially. So evidence production uses, right? Initially, sometimes, as I said, the legal matter takes a while to work, and so we want to quickly give the user something to look at while they're waiting. So we can do a quick overview and a quick summary before we look at the whole document. Then we pull out all the propositions. That's the primary load, the proposition curation for legal. Legal repair is a smaller load because it typically only has to handle a handful of invalid proposals from Gemma from the first step. Then clinical assertion curation turns the bounded note, impression, report candidates into proposed propositions. So that's just a similar pathline to the legal. It's just that the clinical notes are usually pretty small to start with, so we don't have a big sort of problem with segmenting a large note into smaller ones. And then the second column is the use of Gemma for grounded prose. The legal matter prose summary uses canonical legal evidence. So basically reading the evidence to you. Healthcare chart narrative uses a compact type balanced evidence projection. In other words, it wants to go over all of the types of evidence and give you a little flavor of how this person is doing in the chart narrative. So that uses Gemma. And then after an evidence query executes, then you may synthesize a grounded answer in natural language from those evidence records that come back from the query. And there's a small use of language to control. So that's natural language query translation. When you ask a question, it needs to translate that into the query. And as we'll see in the demo, legal and healthcare use Gemma to generate some sample question chips so that users can see what kind of questions the system can support. Or maybe it's the question they wanted to type, and now they don't even need to type it; they can just click it. So what's not Gemma? PDF parsing and OCR. Outline recovery, candidate signals, record normalization, fire normalization, IDs, citations, provenance, validation, deduplication, exact query execution, roll-ups, views, embeddings, and re-ranking. Those are all deterministic or separate model. They may go to the embeddings model. So Gemma proposes the structure or the prose, but the code selects the source envelope, checks the contract, and decides what survives. So the deployment architecture preserves the separation between the deterministic workflow and the language model services. So this is a alphabet soup, I guess you would kind of say, from Amazon Web Service. This is this is the architecture I would recommend for client data. It's a reference architecture. It's not a description of what I've deployed for this demonstration. Um, the reason is it's got a lot of redundancy. It's kind of following best practice, but it would cost you $200 or $300 a month just to keep running, even if you weren't doing anything. So I use a much simpler system because I don't store any actual private real person data. But let's just go through it just in case, because you remember, private AI just doesn't necessarily mean you have to run it on your own hardware. In fact, you probably don't want to, but you do want to make sure that where you're running it, you understand the security primarily and can control every aspect of that. You may also have, you know, other regulations that you have to follow for data residency, etc. So in this particular recommendation, I would recommend, for high availability, having two availability zones, AZs. So just from left to right, you have the public DNS and domain name system reaches Amazon's web application firewall, WAF, an application load balancer, ALB, and that just makes sure that you get routed to an availability zone that's up. You have Amazon Certificate Manager, and that supplies the Transport Layer Security or TLS certificate. And so the first gate you have to get through is the Manage Public Edge, and then the next one is the auth gate, and the auth gate only requests from the ALB security group can even get there to the OAuth 2 proxy target. And then Amazon Cognito uses an OpenID Connect authorization code flow with Pixie and requires two-factor authentication. And then when you get to the third gate, those guys don't have public IP addresses. They have least privilege roles, and they can just do subject or retrieval basically over private links. Every request is logged. So the source, we want to keep our sources are pulled in from someplace, we'll say, over a secure connection, and we need to store them in an encrypted versioned Amazon object store. And storing them locally lets us, reproduce and lets us have something to point to when we're citing the source. The canonical evidence database is the multi-availability zone PostgreSQL. It's also encrypted, stores the type propositions, validation state, provenance. So what else do I want to say about this? Probably it's not the main point of the talk. It is you can do this with a lot of public clouds. This was just Amazon's solution to one that I thought would be good for somebody actually storing customer or private data. The orange box on the right is for the GPUs. So not everything is available from Amazon, or at least it probably is, but I decided to get GPUs from another company called RunPod. And so you have to have controlled egress to get out of Amazon's cloud and into RunPod's cloud. So that's what the controlled egress with the network address translation is for. And you might actually even want to do some more control over what place, make sure you can't get to anywhere else other than those GPU services. All right. So because the legal evidence curation is the dominant workload, burst GPUs matter, right? So on the local M5 plus a llama path, right? I mentioned that I wanted to be able to run this on, totally locally without any access to anything. So that actually does work, but it can be slow for this particular case. And specifically, the legal evidence curation, you get almost a page a minute on average out of running Gemma under Olama on a MacBook. This is a Mac Air, actually, so sometimes it gets hot. And it's got 24 gigabytes of memory that can be used with the GPU, but it's also used for the CPU. So it's an interesting architecture, the Apple Silicon. Then when you run out of capacity on local, and you don't want to buy a bigger machine, you have to look to rent. So there are vendors. In fact, you can now, I think, probably get some of this from Amazon as well. When I looked 3 months ago, it wasn't as clear what you were going to get. And it was clear what you got from RunPod. And so using a kind of a industry, I don't know if it's a standard amount, but the H100, the Hopper architecture from NVIDIA is popular. And if you use this with the VLLM serving stack, right, on a RunPod, you'll end up getting that same workload that running locally on my MacBook is less than a page a minute. It's more than a page a second. And there are also some rates that kind of, vary. These were, I think I checked these a couple of months ago, so they're probably not quite the same now. But it's something where on the order of $4 to $5 per hour running flat out when you're renting this H100. And there's various configurations and different amounts of flexibility and cost. There's interesting trade-offs there. But I probably shouldn't go into that too much. Just the decision table here to summarize is basically the local M5 fits small jobs, demonstrations, and you get maximum locality. The H100 fits bursty documents. For the Flex, you're going to pay a lot more if you don't want to pay for the cold start penalty, right? And the other problem with the Flex is that sometimes, because it kind of has to go and spin up your own, you do get your own GPU. That's kind of the cool thing, but they've got a pool of them, various data centers all over the world. But sometimes, like right before this talk, you try to go and say, okay, I want to, I want to go from Flex because that doesn't cost me anything when I'm not running it to active, so that I'm guaranteed that I'll have resources when I want them. It's a big jump because then instead of paying the 455 or whatever it is per hour of use, it's the 455 per hour, whether you're using it or not, right? So this is actually costing me right now, I guess. And, you can also go, so the server list basically says, we're not going to guarantee you where your server is going to be. So if you have residency requirements, things like that, you can then go to the secure pod where you get the whole pod. You get to control the geography, which data center you're going to reserve it in. It actually does cost less a little bit, but you would pay for the entire time that you have it reserved. So let's look at quick demo, right? So we'll look at a medical patient's chart, and we'll look at a legal matter involving Donald Trump. Why not? Let's see here. So I haven't heard anybody talk in a long time except me. So are you guys still there?
Yes, yes.
Okay, perfect. And hopefully you can see this demo screen. Sorry, I think you may have to expand your screen as big as it is because Jacob before this told me that because I'm sharing an individual window rather than the whole screen, it was looking small to him. But so we have basically four parts of the screen. The top, this left panel, the right panel, and the bottom. So the left is essentially interacting with the evidence or roll-ups of the evidence. So here you have the summary, the patient, basically some summary information about their chart, and this is a narrative that the idea is that the physician can just look at this and immediately see a pretty good synopsis of how the patient is doing. Then we also have different tabs here. So you can look at, for example, the timeline of the patient. You can see that they have records going back for a number of years. You can see trends. These are for the observations are combined by the particular, observation code like systolic blood pressure. And then, we draw the little graph. Now these records are not real people. These come from the Smart on Fire sort of public sandbox. And so they are not necessarily representative of, real world patients. In fact, some of them are dead. But it's hard to get real patient data, and I wouldn't be able to show it to you anyway. So, so that was useful to be able to get this public sandbox really. Longitudinal roll-ups. So here the system has said glycemic control, dyslipidemia, and cardiovascular risk are two topics. So you can drill into those and see about their glycemic control. Look at the sub roll-ups relevant to that, like their glucose, and you can see that we finally get down to an individual measurement, and you can click on the evidence, and it's going to show you that actually comes from a fire record, and you can actually click on that fire record if you want and see the JSON behind that. So that's kind of the big feature I think here is that all of this information is linked to the source, and it's pretty hard for the LLM to deny it, although it could. Now you look at the evidence. Here's particular, this is sort of a type encounter, a type observation. You can look at the source of where those come from. Look at various fields. These questions here, some of them, these are basically generated patient-specific. So you can ask, how has body mass index changed over time, for instance. It's actually going to point you back into the area of the chart where that's displayed. It's going to also give you a natural language answer, and it's going to pull up the evidence that supports it. It's going to give you also a different sort of graphical view of the chart there. You can go and look at all of the evidence in detail that it finds for this. Now, what if you ask something that's a little bit, I don't know, how long will the patient live? Right? That's what you kind of don't want to have happen necessarily, with your arbitrary chatbot. No telling what it would say, but here, because everything is kind of controlled and checked, it just tells you it can't tell you from the provided medical records how long the patient's going to live. Then we can switch to the legal demo, which, as you might imagine, looks similar. In other words, we still have top, the bottom, the left, and the right. I need to pick a patient. Let's do the Trump, right? Here we go. And so we had a pipeline cache hit. So I've already run this demo. And so since the source documents never changed, it comes up very fast, right? And if you look the bottom, you can see the pipeline trace that was this ran earlier and was cached. So we get, this is not a very big legal matter. There's 121 propositions, and there were 8 invalid. Only 3 got repaired in this particular case here. And it generates the prose summary. Sorry, there's something interfering with my screen here. That's okay. So let's look at this one a little bit. The source documents for the legal matters, there's 2. So like the indictment, you can click on that. This is what, it started as a source, just a PDF document with a bunch of counts of falsifying business records. And you can ask a question here, or, first of all, the outline. So it has to kind of come up with the outline just from looking at text signals, like whether it's bold, italic, centered or not. So it does a reasonable job of that. And so you can kind of drill down into, using the structure of the outline to organize the evidence that way. And legal, you can also organize by timeline, just like in healthcare. You see the evidence records, and there's a whole bunch of fields actually in the records. You can see that. So this is the database, some pre-canned views on the left. Again, pre-canned questions are generated for you that are relevant to this particular legal matter. If you find one, you can just click on it. Or you can ask your own, which might be, let's see, what was the one we saw there? What was the catch and kill plan? And so the answer comes back. Catch and kill scheme involved American Media AMI making payments to sources to ensure they did not publicize damaging allegations about the defendant. I think we know who the defendant was before the 2016 presidential election, a practice. So again, that came up really quickly because we had done the work of running this pipeline and building our legal proposition database. And I think with that, Jacob, I'm just exactly out of time, so I'm gonna stop right now and entertain any questions.
Okay, Gary, thank you. We have almost no time, but we do have one question, and basically it's from Shelley. They did the same thing what you did. And okay, one question. Somebody raise a hand. Okay, Thomas, go ahead.
Hello, very nice presentation. Thank you. I would like to ask about the multimodal capabilities of Gamma and other multimodal LLMs compared to Tesseract. Whether Tesseract or the classical OCR is still needed, or whether you've benchmarked these two approaches, either using multimodal LLM directly on the, say, PDFs, and what would the added value of Tesseract be there?
Yeah, so the question I think is how does the multimodal Gemma stack up against Tesseract? So the first thing, you just hope you don't have to use the OCR and you can use the text route for getting information from the PDFs, because that lets you get things like text style, like its size and whether it's bold or italics, and that helps you work out the outline. If you're just using Tesseract, you just basically get the text and that's all. But it's very good and it's very fast. Using Gemma, see, that was the whole problem, right? I mean, Gemma is a smallish model, and you can take like 100-page PDF, legal PDF, and just give it to one of the frontier models, OpenAI or whatever, right, or Claude, and it will give you great answers. I mean, so you don't need to use this system at all. I mean, the problem is that some of the answers aren't right, and you don't know which ones are right and which ones aren't. And the token cost is I don't know, 20, 30, 50 times what it is for Gemma. So if you give the entire PDF to Gemma, it's just going to choke. That's the problem, is you have to segment it in order to get it to, and the same thing, is even, it's even worse, I think, when you're giving it as an image and asking it to extract the text. So, it makes a lot more mistakes and it's really, really slow. I mean, and it has, severe limitations in terms of its context window. I mean, yeah, they say that they support whatever 128K, but in reality, I've found that anything much over 16K, you pay a lot of time for, and a lot of resource. So Tesseract is, I don't know what the underlying technology is, but I'm sure it's not an LLM. It's deterministic, and it seems to be very fast and very high rate of recognition. Whereas I did try giving it to Gemma, and those were the problems that I noticed. It was it would choke on very much input, and if you give it smaller pieces, that would work, but its quality wasn't very good and it was very slow.
Thank you.
Okay, Gary, thank you very much. I want to ask you to answer the question after this presentation on chat. And thanks again. And we need to start another presentation.
Yeah, or you can just ask me again in the panel. I'll be back in an hour.
Okay.